Hello and welcome to Controllers Tech. I have already made a playlist covering the ESP32 MCU using the Eclipse-based IDE. I wanted to continue the playlist, but there are a lot of changes in the IDE, which made it harder for me to keep myself updated with the changes. There are very few videos in the playlist, and even in those videos, some users complain that the library functions have been changed in the new IDE. Also, I have switched to macOS now, and therefore I have decided to make a new video showing how to run your first project on ESP32 with this new IDE. Here on I will continue this series, and keep posting the videos regularly. We will first cover the basic peripherals like UART, SPI, I2C, ADC, etc. Then we will move on to displays and sensors. If there is a major change in the functions, I will repost the video for the specific peripheral explaining the changes. The videos in the playlist will be ordered accordingly, so if there is any confusion regarding the order, please check the playlist. I am going to use the ESP32 development board with 38 pins for this entire series. You can purchase the board from Controllers Tech Store. Both 30-pin and 38-pin development boards are available with us. Alright, let's start the process of installation from scratch. Open the Get Started page on the ESP-IDF website. I have selected the latest stable version at the time of making this video, 5.2.2. We will install the Eclipse plugin, so open the link from here. If you are using a Windows computer, download the installer from this link. If you have a good data plan, better go for the Universal Online Installer. Otherwise, download this offline installer, and install the IDE. The Windows installation is similar to what I covered 3 years ago, so you can refer to that video in case of any doubts. The installer will install all the needed tools for the IDE to run. In this video we will focus on installing the IDE on a Mac OS. Let's open the IDE link, and the prerequisites in different tabs. The prerequisites basically contain the Java, Python, and the Git softwares. Next, download the IDE according to your OS structure. I have a Mac M2 processor, which is an ARM 64-bit architecture, so I will download this one. Now let's download the prerequisites. I will start with Java. I am going to download the latest available version this time, that is version 22. As I mentioned, I have the ARM 64-bit architecture, and I am downloading the disk image file. Let's download Python now. It has auto-detected the OS, so just click download. At last we need to download the Git. The Git is available on the Mac through Homebrew, so you need to first install the Homebrew. To check if it is already installed on your Mac, open the terminal and type brew. As it says, the command is not found, which means it has not been installed yet. Here is the command which we need to run in our terminal. Type in your system password, and hit return. Hit return again to continue the installation. While it is downloading the required software, let's install the other tools. I am going to first install the Java package. I am installing it at the default location. Alright, the Java has been installed successfully. Now we will install Python. Again, I am installing it as the default location. The Python is also installed successfully. The ESP-IDF IDE has been downloaded, but we first need to install the Git software. The command tool is now downloading the Homebrew, so we will wait for it to finish. You can refer to this video for installing the Homebrew on your Mac. The admin has also provided the commands we need to use during setup. Alright, the homebrew has been installed successfully. But if you note here, the homebrew is still not in our path, which means that we can't just use the brew commands yet. The installer does provide the method to add the homebrew to the path, but I will go with the video method. Type cd to go to the home directory. Here we need to create a new ZSHRC file. In my case the file already exists, and there is some STM32CubeMX related path into it. Anyway, just copy this command from here, and paste it inside this file. Now press Ctrl X to exit, and press Y to save the file. Finally hit Enter, or Return. Now if you type ls-l, you should be able to see the file you just created. Now restart the terminal and source the updated configuration. The brew command should work fine now, and to test it, you can check its version. Here we got the version, which means the brew command is now running fine. So we will install the Git using the brew. Alright, the installation is successful. We have installed all the tools needed for the IDE. Although there is one more requirement, that all these tools should be available on the system environment path. Let's check if we can run them from the home folder itself. Python 3 version command seems to be typed wrong. Let me try with Python 3. The Python runs fine, let's try with the Git. Typing Git does not say invalid command, so this is also running fine. Let's try Java now. Again we do not get the invalid command error, so all the tools are available in the system path. Let's install the IDE now. Alright, let's open the IDE from the application section. Click Open. We need to set the workspace folder. I am creating a new folder to identify the ESP32 projects, and I will always use this folder for ESP32. Let's close this welcome page, and we will create a new ESP-IDF project. Here it says we need to install and configure the required paths for creating and building the ESP-IDF projects. Basically it will download the files needed for the IDE to run. This is going to be a one-time setup only, so click Yes. Now click on Add ESP-IDF, and choose the folder where the downloaded files will be saved. I am creating a new folder for this, and naming it ESP-IDF. Alright, the downloading has started, and it will take some time to finish. I am going to skip this part, just let it download and install whatever it needs. Alright, everything is done, and you can see the green box on the top indicating the IDE version. Now we will create our first project. Choose the board you are using here. The ESP-Room32 is a simple ESP32 board, so I have selected it. Just give some name to this project. It's better to use one of these examples. There is also a Blink example, so let's use it. Click Finish to create the project. On the left you can see the Project Explorer, which contains all the files used in our project. Here it has the main file. The PO pin connected to the LED might be different in different board series. Therefore we need to configure this pin in the SDK configuration. Let's build the project once. The build is successful, and the errors in the main file are gone now. Let's open the SDK configuration. Now open the example configuration. Here set the PO pin number that you want to toggle. In case of the ESP-Room32 with 38 pins, the PO1 is connected to the onboard LED. You can also change the blink period, but I am leaving it to 1 second. Click Save to save this configuration. Now build the project again. The build is successful, so we will load it to the board. But before that we need to configure the ESP target. Make sure the IDF target is set correctly. Now choose the serial port, where the ESP is connected to. Here you can see it has detected the target. Now click on the Run button to flash the project to the board. The project has been loaded, and you can see the LED on board is blinking every second. You can also view the output of the log on the serial terminal. Click here to launch the terminal. Make sure the project name and the serial port are set correctly. On clicking OK, a new terminal window will open and it will start showing the log output. The PO1 is used by the UART to display these logs on the serial terminal, but we are using that pin in the project because it is connected to the LED on board. This is why we are not able to see the output of the logs here. I will change the pin in the end, and we will see how the output is displayed. So the LED is blinking every 1 second. Let's say we want to blink it every 500 milliseconds. All we need to do is change the blink period in the SDK configuration. And if you do not want to do it there, you can also change it here in the code ESP-IDF. I am changing it to 500 milliseconds here. Let's build the code again. And now flash it to the board. You can see the LED blinking period is now every 500 milliseconds. Now let's quickly see the output of the logs on the serial terminal. Let's open the SDK configuration, and set the blink number to anything other than 1. As I said, PO1 is connected to UART, which is used by the serial terminal. Now save this configuration, and build the project again. This is the log data that we are expecting on the terminal. It should display turning the LED, and then on or off depending on the current state of the LED. Let's flash the project to the board. The LED will not blink now, since we are using pin number 5, which is not connected to the LED. But you might see the LED turning on when the data is being transferred, and that is because the UART pin is connected to the LED. Now click on the terminal, set the project and serial port, and click OK. Here you can see the logs on the terminal. It is changing every 500 milliseconds, as that's the loop delay. The I in the log indicates that it is an information log. The function used for the information log is ESP-log-I. We will see more about these logs in the upcoming videos. This is it for the video. I hope you understood how to install the IDE on the Mac OS, and how to get your first project running on the ESP32. Like I said, I will continue this series, so you can expect a video around every week. Whenever there are major changes in the IDE, I will make the video again for the topic covering the required changes. That is it for today. You can download the code from the link in the description. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.